Okay, take 2, 12-4, law of sines. Okay, before we get into this law, we're going to talk about another formula for the area of a triangle. So keep in mind a couple of things before we actually give you the formula. Number one is you want to remember or know that this is not only for right triangles. Okay, so you don't have to, the formula that you've had before has been area equals 1/2 the base times the height. You had to know a side of a triangle and the segment perpendicular to it. So that's not the case here. Okay. The other thing that I want to tell you before I present the formula is to remind you that you learned in geometry, hopefully, that normally in math, the capital letters stand for the angles and the lowercase letters stand for the sides, and the same letters opposite each other. So big A and little a are opposite. Big B and little b are opposite, and big C and little c are opposite. Keep that in mind. Okay, so the area of a triangle is 1/2 of the product of the lengths of two sides and the sine of their included angle. Sometimes people refer to this as the SAS formula, area of triangle. Okay, because as you can see, you've got to have, to be able to use it, you have to have two sides and the angle in between them. Okay, so what does the formula say? It tells you that the area of a triangle is, as it said, 1/2 the product of two sides times the sine of the included angle. So that could be 1/2 AB times the sine of C, or it could be 1/2 AC times the sine of B, or it could be 1/2 BC times the sine of A. So it does not matter what letter it is. It's not as particular as something like the Pythagorean theorem. Okay, it's just the fact that you have to have two sides of a triangle and the angle that comes between them. Okay, so find the area of triangle ABC to the nearest tenth if A is 31 degrees, B is 18 meters, and C is 22 meters. Okay, I have three different letters. I have big A, little b, little c. So that fits that formula. So I'm going to say that area equals 1/2 a side, 18, times another side, 22, times the sine of the included angle. Punch that in your calculator, and y'all, as I go through this video, I encourage you to pause it just real quick after I put a formula down, because the next step I'm going to give you the answer. You need to make sure you know how to use the calculator when you do that. So we have 102.0 square meters. Okay, so if you were to take this formula right here, and I'm going to write it again so I can scroll down a little bit. 1/2 BC times the sine of A, 1/2 AC times the sine of B, or 1/2 AB times the sine of C. If you take that and divide each of them by 1/2 ABC, then notice, okay, what happens. I got a BC on top. 1/2 goes away, A goes away, C. They are dividing out, so I'm canceling common factors. So if you notice what is left, it's our law of sines. What's left in this one is the sine of A over A. What's left in the middle? Sine of B over B. What's left on the end is sine of C over C. Again, doesn't have to be a right triangle to be able to use this. To use SOHCAHTOA, you have to have a right triangle. So that's kind of an important thing to remember. Okay. The other thing is from your properties of proportions that you learned in geometry. Okay. I don't know how many of you remember it, but I use this property because it makes the solving simpler. Okay. When I'm doing solving triangles, using the law of sines to solve triangles. So I have this proportion, sine of A over A, sine of B over B equals sine of C over C. Or with my properties of proportions, I can have A over the sine of A, B over the sine of B equals C over the sine of C. So you can flip the whole thing as long as you, of course, flip each ratio, then that's an equivalent thing. And you're going to see as I go through the video how I use that to make the solving a little bit faster. Okay, so solve a triangle given two angles and a side. So I have triangle NPQ. If P is 42 degrees, Q is 65 degrees, and N is 5. So I'm going to set up a chart just like we did with Sakatoa, putting in the sides and angles of my triangle. And I'm going to write down what I was given. Okay. So if I'm given that information and I have to solve, okay, first of all, I cannot solve using the law of sines because I do not have a side and an angle that I don't have a pair. Okay. A side and an angle that are opposite each other. So I have little n, but I don't have big N. I have big P and Q, but I don't have little p and q. However, you should notice that you have two angles. And if you have two angles, you can always find the third because you remember from geometry that all the angles add up to 180 degrees. So if I take those two angles and subtract them from 180, then I will get the measure of that third angle. And now I have a pair. I have big N and little n. And so I'm going to use that to set up my proportion. So I have 5 over the sine of 73. Now, again, I put 5 on top, y'all, because I'm looking for little p and little q. And since that's what I'm looking for, I want it on top. Okay. Now, the first thing I'm going to do is use this part of my extended proportion. Okay. And when you put it on top, y'all, you only have to move something on the bottom to solve it. So that means that I am taking the sine of 42 and I'm moving it to right there. So it looks like this when you put it in your calculator. P equals 5 times the sine of 42 over the sine of 73. Now, if you do not have a horizontal fraction bar, Class Calc does. Encourage you to use it if you don't have it on your calculator. Okay. But if you don't have a horizontal fraction bar, you have to put parentheses at the beginning and the end of any numerator or denominator that has an operation in it. What is that operation? Multiplication here, 5 times the sine of 42. So we also like to put the 5 in front because if people forget to close the parentheses after the 42, then the 42 and the 5 multiply together before you take the sign of it. So you're going to get the wrong answer. So again, pause, put that in a calculator, restart it, boom, and I hope you got an answer of 4.7. Okay. So now that I've gotten P, I'm going to go use the other part of my proportion, and I'm going to move the sine of 65 up to the top. And so that gives me Q equals 5 times the sine of 65 over the sine of 73. Again, pause, put it in your calculator, restart, and get Q equals 35. Okay? Now, fine and dandy, I have two angles of a triangle. I'm given two angles. Well, I'm not always given two angles. Sometimes, I'm only given one angle. And if I'm only given one angle, then you need to consider there's a possibility of two cases. Now, I personally don't want to remember this, so I'm going to tell you what I do. You can remember all these different situations, but what's important is if A is acute, then you have the possibility of two triangles sometimes. Okay, you have this case. You could have two triangles, you could have one solution, or you could have no solution. Okay, if A is obtuse or right, you could have no solution or one solution. You won't have two solutions. So if the one angle they give you is obtuse, you don't have to worry about it. But I haven't seen that very often. So let's go forward and you're going to see how to handle these kind of problems. So the gist of it is I always consider the possibility of two triangles. It would be faster if you would remember what gives you that case and what doesn't, but I guess I'm too lazy for that. Anyway, determine whether each triangle has no solution, one solution, or two solutions. Then solve the triangle, round side lengths to the nearest tenth, and angle measures to the nearest degree. So these three problems we're going to do, I have the others set up on the next page, so you don't have to worry about trying to cram all this in one little space. So 3A, in triangle RST, R is 95, big R is 95, little r is 10, and little s is 12. So again, I'm setting up, and notice that my chart now has an extra column because I'm going to consider the possibility of two triangles. I'm going to fill in what I was told. Big R is 95, and that doesn't change for either triangle. Little r is 10, and little s is 12. Okay, and as I mentioned before, you always are going to start with a pair, And that pair in this case is going to be big R and little r. Always, always, always start with a pair, which means a side and an angle that are opposite each other, or a big and a little letter. Okay? So since I have S, then I'm going to be looking for angle S first. But I'm going to start with what I know, which is the sine of 95 over 10 equal to the sine of S over 12. Okay, remember, when you put what you're looking for on top, all you have to do is move the bottom one to the top of the other side. So the sine of S equals 12 times the sine of 95 divided by 10. Now, I put that on went ahead and put it in my calculator. Remember, whenever you're looking for the angle, that's the inverse sine button. Again, I want you to pause the video, put that on your calculator, and notice what you get. Okay? Because most of your calculators probably said domain error. And if it said domain error, then you need to remember that that is an example of your no solution triangle. Okay? The sine cannot ever be larger than 1. We've talked about that with SOHCAHTOA. It'll make even a lot more sense when you get into graphing, but this is an example. All right, so let's go to 3B. 3B looks like this. I got triangle MNP. N is 32, little n is 7, and little p is 4. So again, I'm setting up my letters, M and P. N is 32, little n is 7, and little p is 4. Okay, so where is my pair? I have a pair here at, I can write it, at N, big N, and little n. So that's what I'm going to start with. So I am looking, and the other one I have is a little p. So I'm looking for big P, which means I'm going to put the angle on top. So I put sine of 32 over 7 equals sine of P over 4. All I have to do is move my 4 to the top of the other side. Again, I'm looking for the angle. So that's the inverse sine button on your calculator. And when you punch that in, so pause, punch it in, see if you get it. All right, so the angle that you get is 18 degrees. And this, when you find the angle first, y'all, this is the only time you solve this problem horizontally. So when I get this first angle, okay, this is the case of, if you can remember from our unit circle, that 18 degrees. Okay, the sine is positive in the first or second quadrant. So the angle in the second quadrant is going to be supplementary to this. So how do I find the other angle? I'm going to subtract 18 from 180. And when I do, I get 162. Okay, so one time you do it horizontally, the rest you solve your triangle vertically. Okay, triangle 1, triangle 2. So I'm going to go finish triangle 1 first. And we come back to the fact of, if I know 2 angles of a triangle, I can always find the third by subtracting from 180. So when I subtract from 180, I find out that the third angle is 130. And you can go ahead into this one. Same thing. I'm going to subtract those 2 angles from 180 and find out that that is negative 14. Can you have an angle that's negative 14? No. So that means this triangle is not possible. And sometimes I just like to scratch it all out. It gives me pleasure that I don't have to do any more work. But I thought about that possibility. So we're going to finish solving the triangle with big M of 130. We're looking for little m, and since I'm looking for little m, I'm going to put it on top. And I put it on top. 7 over sine of 32 equals m over the sine of 130. I'm going to move my sine of 130 to the top of the other side. So in my calculator, I'm typing in m equals 7 times the sine of 130 over 32. Pause. Start back. And I hope you got an answer of 10.1. It is not degrees. What the heck was I thinking? Okay. Too many videos, y'all. Okay. So that is 3B. Now let's go on to 3C. It happens to be of a triangle of ABC. So I'm going to set up A, B, C, little a, little b, little c. A is 47, little a is 15, little b is 18. Okay? So where is my pair? I have big A and little a. So I'm going to go set up a proportion with that. I know little b, so I'm going to find big B, which means I'm going to put the angle on top. Sine of B over 18 equals sine of 47 over 15. Okay, so that means I'm going to move the 18 to the top and use the inverse sine function on my calculator. And when you punch that in, you get that B is 61. Again, found the angle first. If I find that angle first, then I'm going to go across this one time only, and I'm going to subtract 61 from 180. And when I do, I get 119. Okay. No more filling in blanks horizontally. Now I'm going to work vertically. I know two angles of my triangle. How am I going to find the third one? I'm going to subtract from 180 the two angles that I know, and I'm going to get an answer of 72. Okay, do the same thing on the other side while it's in your brain. I'm subtracting from 180 the two angles that I know, and I get an angle of 14. So I'm going to have two triangles in this problem. Okay, if we go, let's go here first. So if I do, then I'm going to, again, use what I know, which is the 15 and the 47. You can use the other ones, but it's always safe to start and use the information you're given. So I was given 15 and 47, so I'll use that. I'm looking for C, which means I also am going to use 14. So if I'm looking for little c, I put that on top. So I have little c over 14 equals 18 over, it's not 18. I fixed that, y'all. Hold on one second. Go away. It is, well, maybe not. There we go. Yeah. Tricked you. Sorry. So sine of c over 14 equals 15 over the sine of 47. And when you put that in your calculator, you will get that the measure of c rounded to the nearest tenth is not 6. Go away. This is why I had to re-record the whole thing, y'all. Okay? Because it's not 6, it actually is 5. Okay, so hope you're laughing. All right, so now I'm going to go do this last triangle, which is a little birdie out my window. Anyway, the last triangle I'm going to do, sine of c, but at this time, instead of using the 14 that I used over here, I'm going to use 72. But I'm still looking for c, so I'm still going to put it on top. C over the sine of 72 equals 15 over the sine of 47. I'm going to move my 72, and so when I put it in my calculator, it will look like that. And when you check your math, you should get 19.5. So we solved two triangles. We have one problem left. Okay. Word problem. Savannah S., shout out to Ms. Oakman, and Leon L. are standing 8 feet apart in front of a rock climbing wall as shown at the right. What is the height of the wall round to the nearest tenth? So if I know that this is 45 and this is 60, more importantly, if I know that's 60, then you should be able to tell me the angle, the measure of this angle right here. And that is going to be, of course, 180 minus 60, which is 120. So that was easier to put it there, but I'm going to go draw an angle. So that is the measure of that angle right there where that man is, not that he's 120 degrees tall. Okay. And if it is 120, if we know this angle is 120 and this angle is 45, again, you can find the measure of the third by subtracting from 180. So that is 15. And I'm actually going to use the law of sines to solve this. And so I'm going to label that side X. So my setup, if I'm looking for X, X is opposite 120 and 8 is opposite 15. So my proportion is going to be X over the sine of 120 equals 8 over the sine of 15. I get to move my 120, sine of 120, excuse me. So X equals 26.769. Now, this particular problem, if you recognize, if that's 45 degrees, then this is a special right triangle. So special right triangle means if I know the hypotenuse, How do I find the leg? I divide by the square root of 2. And when you do, you get an answer of 18.928, which rounded to the nearest tenth becomes 18.9. So that was pretty quick, trying to make it quick so you can practice your problems. If you have any question, please email me so we can do a live Q&A or Google Meet. Thank you so much, and y'all have a great day.